4, and then the next video I'm going to go ahead and do 5 because it is a separate problem. So let's go ahead and just look at this. Okay, so in science class, the students were asked to create a container to hold an egg. So it's like the egg drop project some teachers do. They would then drop this container from a window that is 20 feet above ground. If the equation of the container's pathway can be modeled by h of t equaling negative 16t squared plus 25, how long would it take? So let's just kind of break down this equation, because some kids just don't understand this, and that's okay, because I don't really expect you to retain this in Algebra 1, but it'd be cool to see if you can kind of understand it. The negative 16 part, that's the gravity. Okay? And in the last question we did, it talked about 90 and it had a t, right? That was the velocity given to us. We don't know that information in this question, so you're going to notice we don't have any t to the first power, okay? So if there's just a t, the number in front, that coefficient, will give you the velocity. And then the constant will give you the, I'm going to kind of better organize this. The constant will give you the height. So just the number will always give you the height of where it started if it didn't start on the ground. So the 25 is because you're dropping it from 25 feet off the ground, and then the negative 16 is the gravity that's occurring when you drop it. Okay, and although you're taking, like, you have this little window, and you're dropping an egg, it's going downward, some air, right? It doesn't think that it'd be quadratic, but you have to think that it's starting here, and it's going to go down, and it is dropping straight down, but it's over time. You have to understand that we're doing this over time and saying, okay, at 0 seconds it's 25, but at 1 second it might be here, and at 2 seconds it's going to be at this height. So quadratic's going to model that. Okay, so find the maximum height of the container. So we talked about the whole, if you have a parabola, right, the vertex is going to give you the maximum. So first step when doing this is you're going to find the axis of symmetry. And I'm going to write it as t equals. I'm not going to be mad if you write it as x equals, but I'm just going to write it as t equals because we are using t as our variable. And then it says negative b. Well, there's nothing with the variable of just t, so that b is 0, which makes the rest of it kind of pointless because we know 0 over any number is 0. So at 0 seconds, and you probably should be able to answer this question without doing the math. At 0 seconds it's occurring, so that means when it started. What was the height when it started? Well, the height was 25 feet, so that's the maximum height, but I'm just going to prove it to go through these steps. So hopefully you can just kind of figure that one out after this, but if not, it's really not a big deal. So we're going to find the vertex, and the vertex is what happens when you plug 0, 0, because of this right here, into this equation. I'm going to write it in function notation so we can work on that skill. And negative 16 times 0 is 0, so it goes away. So that gives us 25 feet. So the maximum height is 25 feet, and that is actually where it started, because obviously the egg's not going to like go up in the air past 25 feet all of a sudden. It's not rubber and going to bounce like a bouncy ball, okay? So that is your maximum height. So then we want to say how many seconds will it take for it to reach the container, or for it to reach the ground. And what we have to remember is the height of ground is 0. Okay? For some reason that is forgotten sometimes. So h would equal 0 feet. Okay? So that means you have to, anytime you have to do this, you have to set the equation equal to 0, which means you're basically going to get rid of the h of t because you're saying the h of t is 0. So we have 0 equals negative 16t squared plus 25. Okay, we talked about it here with the b being 0 because there's no variable, just t, right? There's no t to the first power. So if there's no x to the first power, t to the first power, s to the first power, whatever the variable you are working with, you can do the square root method. Okay, you can factor this, but we don't need to. So let's work on some of the methods we used. So the square root method states that you're going to take the constant and you're going to move it over. And you can move that 16t squared over instead, but I'm just going to go with what the typical steps are. From there, you're going to divide by negative 16, and I'm going to move my work up here, I'm not going to simplify that. The only thing I'm going to do is get rid of the negative. So I have 25 over 16 equals t squared. And we would square root both sides. Now, time cannot be negative. Where can I write this? Time isn't ever negative. Okay, we can't go backwards. We can't go to the past. We haven't learned time travel yet. So you can't get negative time. So typically I'd be like, it's t equals plus or minus. But that's not the case because we can't have a negative time. You can only have positive. The square root of 25 over 16, you can think of the square root of 25 over the square root of 16. The square root of 25 is 5. The square root of 16 is 4. So you can have 5 4 seconds, or you can take 5 divided by 4. And I know the answer, but I'm just checking. And that gets you 1.25 seconds. So that egg hit the ground after 1.25 seconds. All right, that's the end of the second video. I'm going to do a third video with the last problem just to split it up. All right. It's going to be in the left-hand corner. Follow that.